Hey, hello everyone. Welcome back to the channel. This is Praveen here. I hope you guys are extremely doing good. So this is the day one of 30 days of free DevOps and cloud bootcamp, where you will learn extraordinary concepts with me, the real-time concepts with me. Whatever I have been doing in various organizations, those will be deployed directly to you in form of videos every day at 7 to 8 or 7 to 10 p.m. The videos will be automatically getting released on my channel. So if you are liking the content, like the video and completely watch the series, because it will definitely help you to keep all the projects, all the things in your resume. So without wasting time, let me screen share my screen and let's go into the week one topics, and then we can see like what exactly is stored for you. So going ahead, let's share my screen. Okay, this is my screen. So let's go to the slide share. Yes. So not here. I will be opening the Kubernetes PDF week one, right? So yes, you are able to see, I hope so, right? And you will be able to see me watching, right? And teaching to you directly, right? So let's see like what are the things stored for you in the week one, basically. Right, let me take out the annotation part. So if you see, okay, let me stop this and let me make it slideshow basically. Okay, here we cannot do, so let me take the slideshow here only. Okay, great. So let me start with the week one topics. What will you be getting? So in the week one topics, you will see various kinds of projects stored for you, various kinds of architectural components of Kubernetes stored for you. The custom resource definition, very much important. Why we need CRDs in Kubernetes, and the Kubernetes RBAC and Helm, because many of you have asked about these things. Your Istio is there, 𝐂𝐤 and 𝐂𝐤 basically for your distributed tracing. Right, basically these are all are components of your monitoring. So we will be doing the distributed tracing, right? And project, end-to-end project I'll be teaching. So today we'll be seeing about, in the day one, we'll be seeing your Kubernetes architecture component, how you can design your Kubernetes architecture, what are the components involved, what are the things you need to make sure before designing this, and basically we will see various kinds of services involved, your manifest files involved, and all those things, right? And similarly, your day 2, day 3, day 4, day 5, everything is stored in this format. And up a star mark here, according to your comments, right? In the comment section, I may change this topics. If you feel that, Praveen, you need some more topics in order to get it add on, you can comment down your thoughts below and I will be adding that in the coming classes, right? I hope that is clear for you. So let's go to the slide 2. This is very much clear, I hope. So today we'll be doing the Kubernetes architecture. So let's see what are the things stored for you and what are the components that are actually there for you. Right, so let's discuss like why basically Kubernetes, right? So we all know that Kubernetes is basically a very much popular, you can say, like tool which has been placed in the market. But why we are going to Kubernetes, right? That is what the main agenda or the main focus point of our class is. So we should be thinking like why basically every organization, let's take your Amazon, let's take your Cisco, let's take your maybe Atlassian, right? All the big clouds, right? Or all the major organizations, your top product-based companies are using Kubernetes to run their applications, right? So earlier, what was the scenario? You all know that before, in the year, let's take 2015 and 2016, at that time, the Docker was very much popular. You all might know that, right? And we have been going through like the journey of Docker, then your Docker Swarm, then basically your you can say like Docker networking. You have all the concepts, right? Everything in place, right? But you see, the major disadvantage here in this using the architecture of Docker Swarm is that everything we need to maintain, we as in DevOps and SRE has to maintain, which is very much difficult for any organization or any team to handle those many things. Because what happens, Docker Swarm, you say this is your cluster 1, you say this is your cluster 2, where two Docker hosts are running, and this is connected with the Docker host, you can say like cluster 0, right? So this entire setup, making sure the networking is there, making sure the swarm is connected, like the components of the swarm are connected to the Docker host, right, in a proper way. All those things are taken care by DevOps and SRE, which is a tedious task, right? Now, scalability comes into factor, your reliability, your self-healing mechanism, your storage mechanism, all those things we have to manually, you can say, like, configure here, right? Definitely it is not going to happen in the long term, right? When you see your vision of having your all your organizational applications getting deployed here, that is where you feel that, okay, this is not my cup of tea, right? Slowly what happened, as the technology evolved, right, as the technology evolved, people started having the conversion of Docker, right, into the Kubernetes, right? So what happened, basically the Kubernetes is running on the surface of Docker as a container, right? So basically it has a Docker as a container, but additional features it gives. So let's talk about few features, whatever we are seeing on the screen. Auto scaling networking, high availability, reliability, self-healing, storage mechanism, everything Kubernetes is giving to us. And very much the beautiful concept here is, you see, whenever you talk about the cloud, whenever you talk about the Kubernetes, the beautiful concept comes into picture, that is your auto scaling, your networking, high availability, reliability, self-healing, and storage, right? So basically the Kubernetes solves the purpose of auto scaling. So as we go ahead in the slides, you will see what is an important factor of having the auto scaling in our applications. What does it do actually? High availability. Let's take, there is a SRE concept. I hope you all might know. If you don't know, just listen here. SRE, site reliability engineering, where you promise the customers that you will make sure your application is up 99.5%. So what does this mean? If anyone asks, Praveen, can you tell me, like, what does 99.5% uptime means? Is basically, you can think like inversely proportional to downtime, right? As much as uptime you have, if you consider this block alone, as much as you have the uptime, basically, right, you see, the lower the downtime. So let's take some other color for your understanding, right? Let me take with this green. So here you can understand, like, very less, in less than like seconds, right? Less than seconds, right? Let's take 10 seconds, or let's take 20 seconds, your application is down, right? You can consider like this. 99.99999, less than 3 seconds, you can consider like this. So these all are calculations which are given by the SRE, right? Site reliability engineering. Site reliability engineering, very much important concept, where all these factors come into picture. In SRE, you will see auto scaling, high availability, reliability, storage mechanism, and whatnot, everything given by Kubernetes. I hope it makes sense. If you get any doubts in this slide, just comment down below, right? And I will be happy to reply to every query you are having. As you go ahead, you will see most important concepts stored for you. So stay tuned, okay? Don't leave in between the video. I hope you have the 500 pages notebook, right, with your pen and with your water bottle. So this is like a full-fledged scale-up mechanisms which we will be doing as we go ahead in the classes. I hope you are liking the content, like the video, and share the channel link with your friends. Now let's go to the slide number 2. Let's see. Now you have understood basically. This is very straightforward. At point of time, it is very difficult to manage the Docker containers, right, spanning over multiple hosts. That's what I have given the design, right? But as you go ahead, you will see, like, Kubernetes has played an important role to us. And let's see, like, what are the things stored for us in the next slides, right? So let's see now main architectural components of Kubernetes, and everything I will explain in deep. I will take a little bit of time here so that you understand what we are talking here exactly, right? So let's see. By Kubernetes architecture, very much important. Every interviewer just asks, okay, tell me the Kubernetes architecture. Many of you might tell on a high level, but today we will see in-depth level of architecture, right? So you see, always in DevOps, there is a concept of master and slave, right? So master is always there and slaves are always there. So master is your controlling node and slaves are your worker node. You can think like this: master, slave. Master is controlling node, CN, and slave is worker node. Now, what is the major difference between these two? As we see this architectural diagram, you will understand that, oh, okay, that is basically your control node or your worker node. So let's go into the deep dive. So basically internet is there. Internet is basically when you are trying to access directly from a public, you can say like public place. Let's take you are sitting in a cafe, you are sitting in a home, right? Or you are sitting in any geographical location, right? In the world, right? So you can say like in the world, any geographical location you are sitting. So basically what is happening is you have the internet with you. Yes, with that only you are trying to access your Kubernetes applications. Now, let's see what are the main components here we are able to see. Now, in the master node, this is the node. Basically, a master node is a server, right? Which manages the entire flow of Kubernetes. So I would say, if you see one by one, what are the components? So just a basic example, there are 4 components in this master node. One is etcd, your kube scheduler, kube control manager, and kube API server, right? So these are 4 components. And if you see the worker node A, right? In the worker node A, what are the 4 components? Again, you will see kubelet 1, kube proxy 2, and you will see like Docker, right? This is your 3, and basically your container runtime, basically 4, right? This is like your container runtime. It gives the runtime. You can think like runtime analytics of various containers present in your worker nodes, right? Now, I hope I'm making it sense. Now let's see like what exactly happens when a person hits the kubectl command. Now, very important, very straightforward also. I will clear this. Now in your brain, I am just injecting the data. Like in master node, there are 4 components. In worker node, there are 4 components, and all these components are interlinked with each other at every point of time, right? And now you see, with the design, what we are going to do here, I will take a little bit of time so that you understand what we are trying to achieve from this concepts, right? Now, if you see in the master node, right, as I have told you, the 4 components is API server, etcd, kube scheduler, and control manager. And similarly, in the worker node, you have 4 components: kubelet, kube proxy, your maybe you can say like container runtime, and your Docker, right? So these are the 4 components which are very much important. And as we go ahead, you will see like what are the things it is stored for you, right? Now let's think like this. You are so let me go ahead with one by one components. You will understand what exactly we are doing. Okay. Now API is basically application programming interface. Application programming, right? Programming interface. Now, what happens here in this case is you will understand like what exactly this is. Okay. Now, whenever you want to talk with the Kubernetes master node, you have to call with the command kubectl, right? Now, you just see what is happening when you hit kubectl. The API server of Kubernetes gets the data of incoming traffic, you can say like kubectl. And now you see there are 2 components here, internet, and this person is hitting. So this is, you can understand like Kubernetes administrator basically, or Kubernetes developer, right? CCAD, right? Kubernetes developer, right? So in this developer and administrator, both can be using the kubectl commands, as well as some teammates who are actually willing have the access, basically they can use it, right? Now you see what I'm trying to do. There is 2 files if you are seeing, right? So let's see like what exactly it is. exam.a.yml and exam.c.yml, right? Now you see what exactly these are doing. Okay. Now you see guys, application programming interface. Now when I talk about your application programming interface, you do a REST call in the sense /API/v1/API/v2. I will show you this hands-on in the Kubernetes project of week 1, right? But as of now, just try to understand any endpoint where you see this kind of data, v1, v2, or beta 1. Beta 1 is basically in testing phase, right? So you see any components like this, that is basically your API endpoint, REST call you are making, right? So you see, this is basically Kubernetes manifest file. Okay, manifest file. Now I will show you with the manifest file components like what exactly is going to happen in the master node and worker node. Now you see what is my API version, extension /v1 beta 1, right? API version, kind, metadata, and spec. So let's discuss about a little bit of things here. So basically you are seeing in the manifest file, the 4 components: API version, kind, metadata, spec. If anyone asks you, can you design a Kubernetes manifest file? Just in your brain, you should have the 4 components flashing on your brain: API version, kind, metadata, spec. Now, what are these doing? Let's see. API version is basically the REST calls, which this manifest file talks with the Kube API server, right? So API server has this extensions basically. Kind, basically kind is an object, okay? So kind is an object. So let me clear the screen so that you are able to understand like what exactly we are doing. Okay, kind is an object, or you can say like resource, right, in Kubernetes. Okay, so whatever type of object you are going to create, right, or type of resource you are going to create, that is basically your kind, right? Now you see metadata. Metadata is nothing but your labels or your data, right? Or your, just you can say like when you go to buy a product, what do you see on the product? You see the barcode, right? And in that the MRP and when it has been manufactured and all those things will be there. So similarly, you can consider like name is application A and namespace is namespace -1. Now you are seeing this namespace -1 here. So let's talk about this. What is namespace? Now, namespace is an imaginary area. Okay, let's think you are sitting in a room, and in your room, basically your room, wherever you are sitting, imagine in your brain that is your Kubernetes worker node. Okay, now in your room, what are the components present? You see there is a bed, there is a cupboard, there is a chair, right? Now what are these things? You can consider your cupboard, right, your chair, right, and your bed as the namespaces. Now on the bed, what you have bed sheet. On the chair, what you have? Maybe cushion. On the maybe on the cupboard, inside the cupboard, what you have? Clothes. So all the things which are kept on that are your pods, right, to in a general understanding. And your cupboard, your chair, your bed, these are like your namespaces. Now what I'm trying to tell is, under the namespace cupboard, you have clothes, you have your stationary items. So whatever you can keep on cupboard, in cupboard, so basically all those items are placed inside cupboard, right? So I cannot put my cupboard items on my bed, right? That will look not good, right? So basically namespace is distinguishing between the applications, right? At the same time, it creates a boundary for your application pods, right? So let's think like in cupboard, what are the pods I told you? One is clothes, one is stationary, one can be your gaming, some components can be stored, your headphones can be placed, right? So all those things are placed inside your cupboard, right? Obviously, right? So there are 4 pods, right? We can think like that. Similarly, if you see the other namespace on chair, what you have the cushion on chair, you have the mesh on chair, right? And different kinds of other components like wheels and everything, right? And that's how the namespace is defined. Basically, it's an imaginary space, right, where all the applications are deployed one by one. And these 2 namespaces, right, are segregated and are forming an imaginary boundary, right? Now, replicas, I will tell you as we go ahead. At any point of time, it means I want my one pod to run, one pod, one application to run, right? Specification. Now, my pod is there. My pod name is what, guys? Application A is my pod name, correct? And what are the specifications inside the pod? Pod is basically having a container, right? So the architecture is, this is pod. Under this, you have a container. And under this, you have an application, right? Pod, container, and application. Now, pod is like designed. And under that, what is the container you have? See, container name is application A and image is image A. So this application is formed with image A, correct? And what are the resources? Now, see, guys, what is a container? Now, container is basically your Linux system, correct? In a simple terms, what is container? Container is your Linux system, right? Very, very simple, very, very easy to understand. Container is your simple Linux systems. Now, what I would say, right, in my Linux system or for my container, how much CPU I need or how much memory I need. So basically, this is the place where I'm telling requests and limits, right? So what is request? At any point of time, my CPU will be 250 MB, right? And basically your memory is also like 250 M, right? So basically, you say like at any point of time for my Linux system, I should have these two. But if it is trying to scale up, if the load is more, if the requests are more, till how much extent it can take from Kubernetes nodes, basically 1 GB, 1 GB and 1 core it can scale up to. Clear, everyone? I hope I am making it sense, right? Clear? Now you see, guys, there is one more important concept here. Now, I hope this is making it sense. Let me clear the screen, right? Now let's talk about this part. So basically, we have designed the kind as deployment, which is basically a pod, and the pod is having the container, right? This was the till now structure we have discussed. Now, in Kubernetes, for every pod, guys, for every pod, there is a service getting created. Okay, this I will tell you as we go ahead. Okay, for a pod, for a application, there is a service getting created. So this service basically takes care of your routing, right? So basically, when someone is www.praveensingampalli.com, right? So that will first hit, basically there is one more component which I will talk in a little bit of time as week progresses, and it will hit the service, and service will redirect the request to the pod. Now you see what is the kind. So kind is service here. So another new component I'm introducing. So basically object, kind is service, metadata same like labels, service A, namespace 1. So this is also service A, right? Service A, it is present in namespace 1, right? And you see application A, right? See, in the same namespace 1, because we are mapped here only, right? Now you see labels, again, application A, specifications for service. So what I told you, service is basically your routing, right? Suppose a request is coming into the service pod, where it should redirect to, right? So if you see when a request is coming, so you see the type is cluster IP. Now in service, there are 4 components. We will discuss as we go ahead, but you see as of now, there is a cluster IP type service. Now I will just write it for your understanding. Cluster IP is a type of service. Clear, everyone? Now, because ports are very important for the service, now you see port, node port, target port, and port. Now, what are these things? I will just tell you in the example. Very, very interesting example this will be. Now let's talk about the Kubernetes architecture. I hope you are able to guess these things, right? Now you see when a person hits kubectl, all the data which is present in this YAML file is converted into the object or a resource. Now let's see how it is happening. The Kube API server takes all this data and it actually transfers this data to various places. Now here, if you see, your etcd etcd is a key value pair database, Now, because Kubernetes itself is a software, it also needs a database, right? Obviously, any software which is running needs a database. So you see, YAML is basically a plain script which has the key, right? If you see, A is to B. So this is your key and this is your value. Very, very simple, right? Very, very simple. Now you see the beauty of the architecture, right? I hope I am making it sense. If you have any doubts, comment down in the comment section, right? And definitely share the channeling, because as we go ahead, there are many, many good things coming onto this place, right? Now, if you see, the Kube API server is transferring the data, right? And both way communication. This is like 2-way communication happens. The database, right? Now all the data which it sends, it stores in the etcd, right? And basically your control manager is your brain of the Kubernetes master node. Now I will say like this is your brain, right? And this is your, maybe if in terms of, you can consider like your eyes, which takes the incoming data, right? So from human body perspective, which is the first component of human body which sees the data, right? Incoming data. So our eyes, and after that we process the data on our brain, right? This is our control manager, right? And after that, what we do, right? After that, we process that data from our brain and we try to do the action. Suppose I want to take this pen, right? So how I have taken this, my brain given a signal to this pen, right? So similarly, scheduler is nothing but whatever the Kube control manager tells the task to be done, this does all the tasks, right? For example, in a simpler terms, let me clear the screen for your better understanding. You will love to see how the pods are getting deployed. Now see, let's think like this. This entire manifest file is converted into a ball, right? This ball is basically your pod of name application A, correct? A, right? Now this pod is coming, and all the data of this pod is saved in the database. And after that, this control manager checks basically, right? And checks and tells which worker node is available for this pod, right? Because the control manager task is to control the entire Kubernetes clusters. Now, if you see, this is worker node A. Similarly, I have worker node B, right? And it is not having any memory, right? Not having, you can say like CPU. Then obviously this control manager will schedule the incoming pod. It will process all the data and it will tell to the kube scheduler that, hey boss, you go and deploy, right, to the worker node 1. Now you see which component is talking with what. This is very important. Now, API server, our eyes, right? And this is our brain, right? As I've told you. And this you can think like in the brain, there is some storage component which stores our data, right? And this is like our hands and legs, right? Which from where we do the tasks, right? So the kube scheduler, once the pod comes in, this kube scheduler actually schedules. I mean, the control manager tells to the scheduler that, hey boss, you deploy in worker node 1, and see, everything is transferred again via the kube API server only. See, this pod is coming, coming, and kubelet. Now, the four components, I hope I have explained: database, the scheduling capacity, control manager controls the various kinds of networking, controls the entire Kubernetes clusters, controls the scale up, scale down of the pods and everything. And this is basically your incoming traffic API server, right? Now, if you see the kubelet, now this is the first component in our worker node. Now, kubelet is nothing but which always talks with your master node, right? Which always talks with your master node in order to make sure it takes the data. Now, if you see, now the data is coming here and it is stored here, right? And if you see, once the kubelet takes the data, it assigns to that particular namespace, it creates the namespace. And then if you see, I have two objects, right? O2 and O1, right? So if you see the service A, guys, very beautiful name, service A, and you see pod A1, guys, pod A1, application A1, right? Application A1, right? Clear? Now, the beauty is, see, from one file, these two have been designed. And if you see the service, what it is doing with the ports. Now let's see on the ports terms, right? Now Docker is basically because for every worker node there is a Docker which has to be installed, which makes sure on the underlying worker node all the pods are running, because Docker is an important factor, and Kubernetes is built on the Docker itself. And your container runtime, right? Basically, container runtimes helps to take or collect the container data, runtime container metrics, right? Kubeproxy controls the networking of your entire pods, right? And make sure your internal pods are talking with each other and everything. Now, let's see like how here the things are, okay? So let me clear the screen and let's see like what exactly we are going to do here. Now, guys, very, very important. Now, you see, from this end, this is your organizational end. Let's think like this. You are into an org ABC and you have completed your part. And now this is an outside person who is trying to access my Kubernetes. How is going to access? Now, remember, there are some ports here. I told you, right? Now, you see, when the person is hitting www.myexample-app.com, there is something like L. So L means load balancer, right? I told you one component is there. So load balancer basically balances the load, right? Balances the load, very, very much important in the terms of your scaling, reliability, architectural components. Now you see this load balancer is redirecting to which component, guys? Which component? You see, it is redirecting to cluster node IP. So basically, when you see the cluster node IP, there is like 31,198. So basically, this ranges from 30,000 plus port, basically 30,000 plus to I think 32,000 or some exact range is there. Under this only this you can say like node port stands, right? Now, if you see what happens, right? So usually what happens, if you see, right, this traffic routing, you see, this is a cluster IP, right? Now type is cluster IP. So basically cluster IP we have got. Now you see there are two incoming traffics. Now person can come via this. So basically this is a node port only, right? Node port. So node port is nothing but your incoming gateway for your node, right? Worker node, this is incoming traffic point for your node. Suppose I have two worker nodes, I can have two things, right? Now, if you see, type is cluster IP, but my node port is basically this, right? Now you see 31,197. Now, if I'm hitting 130 IP address is to node port, so what is the happening here? See, right? 31,197 is this value. It is basically your node port, and it is redirecting that request to the target port. Now, what is our target port, guys? 9897, which is service, right? Suppose I hit IP address colon the node port, right? Now, what it is happening? It is coming, the request is coming, to the node port, and it is hitting to the service. Service is having what IP? 10.98.32.197 colon 9897, right? And from the service, where I'm redirecting to the pod ports 9897, 9897. Suppose I want to run my pod ports in 9800. Which component I will change, guys? This component, the port component will be changed, right? Understanding? I hope you are getting what I am talking, and how these two are interconnected. Now, suppose there is object 1 and object 2. Now, how my service will know that it has to redirect the traffic to the object 2, which is basically a pod, is via the selector. Now, if you see, I have given the name of selector app name as application A. So you see app name as application A. So the beauty is both will be like brothers and sisters. Okay. So if you see, the application A component is with the this one. Clear, everyone? I hope I am making it sense, right? Clear? Yes, no? In the comment section, definitely mention what are the things you are looking for additionally, right? And if you see, N stands for node port, right? Service stands for service, right? Pod stands for pod. Container, again, I have told you everything. So this kind of structure means container. When you say the box, it is pod. And when you see the dashed lines, it is service, right? L means load balancer. And this is basically, this component is your node port. Hexagon is basically your node port, right? And basically Docker image repository, if you see the image, we are using image A. So this will be deployed here, right? Very, very simple. I have explained very, very beautifully and very like your basics, because I know that freshers are also there in this particular section, right? So I hope I am making it sense. Any questions, comment down. So let's move to the slide number, next slide, like what exactly is stored for you. So now service in Kubernetes. So that is what I was telling, right? Various kinds of service are there. So you see one by one. Services in Kubernetes, pods are naturally ephemeral. Ephemeral in the sense, ephemeral, I will tell you in a simpler terms. Now, suppose you create a pod, right? And let's say like pod is getting restarted, right? Pod is in exceeded state or crash loop back. So these are basically the condition crash loop back. These are basically conditions when your application doesn't comes up. When your application is having issue, these are the error outputs you see, right? Right, restarted when your application is not up or your pod is not up and running. Basically, the pod states. Okay. Now, ephemeral is something, right? Suppose there is pod 1 and this service 1 is okay. Without the service, I will talk. Now, I am directly hitting my pod 1 from the internet. Okay. Now, what will happen? Suppose my pod gets restarted. Now, what will happen, guys? Because my pod is ephemeral, it doesn't store any data. Okay. It doesn't store any data till now. What happens? The data which was actually coming in, the pod has not stored anything, any transaction, anything. And now, suddenly the application will be down. There can be use case, right? Ephemeral in the sense the pod is not storing any of the data, and once the pod getting restarted or crash loop back, all the logs, all the data of the pod is gone. It's lost, right? So, and also when the pod is getting restarted or crash loop back or exited, their pod IP, when it is coming up new again, pod IP will be changed. Very, very important, right? Suppose I want to hit from the external world 10.111.32.80/32. Okay, not /32 colon. Okay, not like this. 10.11.32.80 colon. Let's think like this. 1197. Right? Now, this was the pod IP till now, which I have. Suppose this pod got restarted. This IP will be changed to what, guys? 10.21.33.80:1197 only. Node port is same, right? Now the IP address got changed. Now, how you will tell to the load balancer every time, like, okay, my IP got changed, or how these things are actually helping you is basically you have a pod 1, your service 1 will be there in front of this, and this service 1 will be redirecting your request to this. I hope I am making it sense. Now, service can have name and port. That is what we have seen in the previous slides. And when a pod is created, it can go attached to the service itself. When a pod is created, the service can be attached to the pod itself, right? It acts as a service mesh. Tomorrow we will see, or day after tomorrow, I think day 3, I have kept you your service mesh and Istio, right? And multiple pods can be attached to a service. So suppose service 1 is there. So basically service is routing pod 1, pod 2, pod 3, right? Any kind of service it can make. And service basically has 4 components, right? First is your load balancer. The service can be load balancer, right? So I have 4 pods, means the load will be balanced, correct? Right? Similarly, the service I have told you in the previous slide. First service is load balancer. We will see load balancer, right? If you type right kind load balancer, one is external name service, external name. It will give you some endpoints like www.praveensinghampalli.com, right? The endpoint of the URL, right? Then your cluster IP, which is basically important for your clusters to talk between each other, right? And node port, the entry point of the worker node. You can think like this, okay? So there are 4 components in the service. One is load balancer, external name, cluster IP, and node port. Very, very much important. Load balancer, very simple, balances the load. The external name gives the endpoints for the pod. Let's take I want praveensinghampalli.com or xyz.com. It gives that. The cluster IP, when 2 clusters are there, they want to talk between each other, the cluster IP is important. And you have your node port, where the entry point inside the worker node or any kind of node, right? So I hope I'm making it sense. Let's move ahead. I will clear the screen. Okay, I have kept it here. So just see cluster IP, right? Default type, and it can get 1 IP address. So basically when you type right kind as cluster IP, let's think like this, right? Or if you are not mentioning also, that's fine, right? If you mention like kind as service, right? Sorry, not this, kind as service, and you type like type, right? And if you don't mention anything here, then the default is cluster IP. Okay, that's why default type is cluster IP, and we can configure cluster IP to achieve, right, pod to pod communication. That's what cluster IP is, basically pod to pod communication, but it can't be accessed over internet, right? Suppose you have 2 clusters, cluster 1, cluster 2, and pod 1, pod 2. Now, how this communication is happening? Because of CIP, that is your cluster IP. And now you have this, and this is your worker. Okay, this is your cluster, this is your worker node, this is your cluster, and you want to talk inside the pod, then you will come like this, like this. Okay, what is node port? Node port by default creates a cluster IP by default. That's why if you see, if you give type as cluster IP in the kind, right? So let me show you in the back, just to make you understand what exactly we are talking about. If you see type here, we are giving cluster IP. If you give node port, right, then also node port is created. If you give cluster IP is created. Okay, and you say like node port, right, like this, right? So see here, name service spec cluster IP. So I am creating a cluster IP of type, right, and the node port is like this, target port and port, right, and the selector is application C. Now for the application C, if you see the target port is 9899, right, and the cluster IP, it is coming from the cluster IP data. Okay, clear? Now let's move forward. Let me clear the screen. Now default kind, when you create a kind as service and you don't mention any type, right, the default, it is going to create the cluster IP. And if you say the type as node port, right, node port, then it is going to create a node port, and it creates, and node port by default creates a cluster IP. Okay, now in the background, when we say a node port, a port will be opened on each and every node. That's what I say. This is cluster. In cluster, you have 2 worker nodes, worker node 1 and worker node 2, and you say node port as a service, then this is what the node port is. Node port 2, node port 1, and by default the cluster IP will be created. okay, for this node port. That is what it is telling, right? And this port will be redirected to the cluster IP node port and can be accessed over the internet. So cluster IP basically for your cluster to have an entry point, and node port is for your node to have the entry point. Load balancer, we can create the load balancer to the cloud provider services like AWS, GCP, Azure. Example, load balancer by default creates node port and cluster IP. Now there is a hierarchy, guys. Cluster IP comes first. If you create the node port, the cluster IP is defaultly created. If you create load balancer as a service, these two will be automatically created. That is the beauty. Okay. And in AWS, if you want the load balancer, then automatically this load balancer will create a node port and a cluster IP. And also in AWS, if you go to the EC2 service and if you go to the load balancer, there will be a load balancer created by your Kubernetes. Okay, which we will see in the coming class, right? Very, very simple. Service, again, I am telling service is nothing but which is the front end of your pod, and this is the pod. So basically the traffic routing, right? Traffic management. That is what cluster IP, node port, load balancer, right? If I type right kind as load balancer, it means my object or the resource is going to create a load balancer in AWS, and this will be balancing the load on the pod which I have created. Very simple. Okay, clear all drawings. I will go to the next slide. Now let's see what is replica set deployment, and probably we will see some manifest files designs. Now let me take you through this. Now what is replica set basically? Replica set RS and what is deployment? People generally ask this question, what is the difference between a replica set and a deployment? So just see, again, I am telling, whenever someone asks what is the Kubernetes components of a manifest file, you say like API version, kind, metadata, and spec. Other than this, anything is there. Other than this, everything is under this, right? So you see API version, kind, metadata, and spec. API version, as I've told you, the versions starts from API/v1, API/v2. And everything I will show you in the hands-on from where these values are coming. Okay. And kind, you see, this is the third kind I am introducing to you all. The first kind was deployment, correct? The second kind was your service. The third kind is your replica set, right? Now you see metadata. What is the name of the replica set? Nginx app, right? These are labels related to replica set resource. Nginx tire frontend specifications. How many replicas for a particular pod I need? Nginx pod. So this replica set works on the pod called Nginx. How many replicas I need, guys? 3. At any point of time, I need my 3 replicas to be running. 3 replicas of pod to be running, right? Selector match labels. Now you see match labels in the sense, this is the syntax replica set uses to find the pods. Now match labels. Now labels are nothing but whenever you create a pod, you give the name, right? So that is your labels in the metadata, right? And tire is front end, right? So basically, my replica set will work on the pod with the label front end. Okay, label is nothing but in the metadata you would have given, right? Correct. Now you see template, metadata, labels, tire, front end, anything, right? Template basically, if you are using any other template or labels, any other things related to pod, you can give it here, right? And this is basically selector. Now you see, this is the syntax replica set uses to find the pods, and this is the template and labels related to the pod. To find the pod, we use match labels, match, right? You do the match, right? Suppose there is some same things, you say like match has happened, right? So that is what this match is all about, right? Now you see, I will just tell about what is this replica set all about. So let me clear the screen here. Now you see, it guarantees the declared number of pods will run always. It is the most important feature of high availability and auto scale. Now, if you remember in the slide 1, we have discussed auto scaling, high availability, security, networking, right? So all those things are very much important for this, and it will help you to make sure what exactly you need, right? Replica set, when you say kind replica set, it goes and attaches to the pod, and it makes sure that at any point of time, the pod will be having like this, right? 3. Suppose if one of the pod goes down, it is in excited state. What this replica set will do? Because it is covered on top of the pod, it will create one more thing. Simple. Okay, replica set is basically making sure at any given point of time, you have all the components in place. Okay, that is what it is. And all the pods are up and running. So basically it makes sure whatever you give the match labels as your pod, it will make sure it is up and running. Now you see deployment. So in the deployment, what do you see here? Now deployment, so I told you, right, kind deployment, again, API version, kind, metadata, specifications, and template. Template is basically when you want to use, you can use it, but yeah, it's coming under your specifications only. Okay, so 4 things are very much important. Let me clear this. Now you see deployments creates replica set in background to maintain the desired number of replicas. We can use deployment for stateless applications. Now there are 2 important concepts in Kubernetes. One is stateful and stateless. Now stateful and stateless. Okay, now stateless, okay, means this pod is not going to store any kind of data. Okay, it just is an application which takes the incoming traffic and sends it to the database or some other endpoint. Okay, but it doesn't store anything. Now stateful stores the data. Okay, so you can say like config maps, right? Some kind of thing, secrets. Okay, some kind of thing, some kind of data this pod is particularly storing for us, right? Now deployment creates replica set on the background. Now deployment is more powerful. You need to understand deployment is more powerful than replica, right? Replica only manages the desired state, but deployment creates the pod, at the same time maintains desired number of replicas. So always deployment is greater than replica set, right? And we can use deployment for stateless. So as I've told you, most of the applications are on deployment only. Okay, and deployment is highest resource in Kubernetes to maintain availability. As I have told you, deployment, D for dawn. You can think like this. Dawn is always superior. Whenever someone asks deployment, just close your eyes. Okay, D, deployment. Deployment is the most superior kind of Kubernetes, and it creates the replica set. It creates the pod. It makes sure high availability is there, right? And desired number of replicas are always available. Scalability can be used to scale at runtime based on traffic, right? So you see API version, kind, metadata, spec, replicas. Now you see, guys, very important. Now here in the metadata, you are telling like some labels you have attached. Now you are telling specification replicas, right? Here it is 3, here it is 10. Match labels, app nginx, strategy, rolling update. Now here one important thing. Now what is rolling update? I would like to tell you. Very important. Very important. Now what is rolling update? Now suppose you have one pod, guys. Okay, pod is an application, right? And in a container, right? Now this is pod 1. Now your incoming traffic is here, coming. Now what is happening now? When you are in this, what version is there? 0.1.2 version is already running. Let's think like this. On August 1st, basically I'm recording at 2 p.m. of August 1st, right? And it is like your application is having the version of 0.1.2 and it is running here. Now the beauty is, just see here, what is the beauty? Now my team is going to deploy this via Jenkins and the version is going to update 0.1.3. Okay, the app version. Now if you see, guys, very important, suppose during this version deployment my pod is not coming up and it is in exceeded state or crash loop back, or it is not getting any of the values it needed, then what happens? Rolling update. It means that it will again roll back to the previous working version. Very important concept. If someone asks what is rolling update, you should be able to tell after watching my video that when an application is deployed and when a new version we are trying to deploy on the same app and it is not working, then the previous version will be backed again and it will be stable, right? So rolling update, max unavailable and max surge, right? We ask for 10 and we are okay if 9 are running at time of upgrade, right? So you can think like that. So max unavailable, it means that you are telling at any point of time you can tell like 10, but if any one pod is not there also, that's fine. Okay, now here you see max search 2, we ask for 10, we are okay, the time of upgrade 11 are running. So max unavailable, right, 9, and max surge 11, right, +1 and -1 kind of. Okay, now template, app, specifications of containers, nginx container. So basically I'm creating a container of nginx and it is having a pod p1, right? And what is the container port, guys? 80, right? So everything is designed in a very beautiful manner in Kubernetes, and you should always remember that It is very much important. Rolling update basically takes care like what exactly it is needed, right? And what at given point of time, how many pods I can have, how many minimum pods I can have, right? And it maintains the scaling also via replicas, right? Now let's move forward. Let's see like what are the other things it stored for you for today's class. Let's see. Okay, daemon set, very, very much important. Now, what is daemon set? Now, this is one more kind I am introducing. Now, kind daemon set, guys. Now, what is the difference between deployment and the daemon set? DAEMON. Very much important, guys. Replica set, daemon set, and deployment, they will ask. Replica set maintains the pod at any given point of time, maintains the number of pods, I would say, number of pods at any given point of time. Deployment is basically your it maintains your replica sets plus it does the pod deployment, right? Daemon set, and basically this deployment is not handled for any particular node. So what does that mean? Suppose you have worker node A and you have worker node B, and your Kubernetes master node will tell this pod to go in any worker node. Okay, we are not selecting here, but in the daemon set, it means that okay, let me explain in simple terms. If you are selecting a deployment kind, it means at any given point of time, okay, at any given point of time, you have the pod getting deployed in one node. Okay, suppose I am deploying a pod P1 in Kubernetes worker node. Okay, I am deploying, it is coming via cluster and it has a worker node 1, worker node 2. Okay, and it will go to worker node. So what do you see? The pod P1 is coming, cluster it is hitting, and it is coming to the worker node 1. It is not going to worker node 2 because it is already here. But in daemon set, very, very beautiful. Daemon set is similar to deployment, but there is only one difference. Deployment makes pod available in any node. Okay, I think here I have made it wrong. Okay, I will make it in simpler terms. I'm correct only. Deployment makes pod available in any node. So basically it is node 1, node 2, right? And you can say like deployment is going to this node or this node, any node, whatever the nodes are there. If you have node 3, it can go to here. But daemon sets make sure at any given point of time, your pods of kind daemon set are running in all the nodes. So only difference is daemon set makes sure your pod is running in all nodes, okay, whereas deployment, it is in any node, basically any one node. Okay, any one node. Okay, so that is what the major difference is. And where the daemon set is used? For your monitoring, right? Suppose I want my node to have some additional pods which should be 24/7 up and running. So you see, if I use some monitoring pods as a kind daemon, right? So you see, I am telling this Fluentd, Elasticsearch, Kube system. I will talk you in the hands-on, right? And you see labels, specifications, templates, right? Specifications, right? Under templates, you see under spec, under template, spec, you see Elasticsearch, Fluentd, limits. As I have told you, limits is the minimum quantity, and request is the maximum that it can take. And volume mounts, very, very important. So if you remember, what is volume mount? Now you have some pod and you are trying to have this pod logs, okay, into the Kubernetes system, into the worker node system, right? Worker node is basically an EC2 instance only, probably, right? So var log, we are mounting that name of var log into the mount path here. Okay, now volumes, I'm creating a volume name var log, and host path is this, right? So volume mount, volumes creates a volume path for me, right? So volume mount, right? Mount path basically. Okay, so that is what the components are. So I hope you have seen all the things, right? So let me summarize it here. So we have started with your Kubernetes architecture. We have started first with why Docker and why Kubernetes. Why Kubernetes is more superior than your Docker. Then we have started with your Kubernetes architecture, where we have discussed your namespace, different kinds of objects in Kubernetes, master node components, worker node components, cluster IP, node port, load balancers, right? And your external names, right? And we have discussed about your volume mounts, match labels, Then we have discussed about replica sets, manifest file, how the traffic is actually managed in the Kubernetes, right? And we have also seen limits, requests, very much important, right? And most of the things I've covered from the basics. I hope you have liked the video. Let's see like if any other things are there. I'm not sure like how much time I am taking here, but let's see. Okay, day 2. Okay, that's all for day 1, guys. Day 2, Kubernetes installation in AWS we will do because our project is on that. And day 3, you will see on top of this only after this tomorrow. Tomorrow I will be releasing the day 2 for you all. In the day 2, you will see like what are the important components are placed, and you will also see what are the next steps which we have in the week 1. I hope you have liked the video, you have got the quality content. Join the Telegram group in the links in the description so that you get all the documents free, and definitely like the video if you are liking the content, and share the channel link with your friends. This is Singham signing off. Meet you all in tomorrow video. Stay tuned, stay happy, and have the notebook and pen, and make sure everything you are noting down. Thank you. Bye.